Welcome to Chapter 3, Section 3, Day 1, Sum and Difference Formulas. So this is a lot of stuff, so we might take it a little bit slowly. We might end up spreading this over a few days of class. So we're looking now at the cofunction properties, where the cosine of either 90 degrees minus an angle or pi minus an angle, again, if you're looking at should be, instead of pi, shouldn't that be pi over 2? I'll double check that. But 90 degrees is pi over 2, not just pi. Pi is 180 degrees. Anyway, the cosine of 90 degrees minus an angle is the same thing as the sine of the angle. The sine of 90 degrees minus an angle is the same thing as the cosine of an angle. That works with secant and cosecant as well. The cosecant of 90 degrees minus an angle is the secant of an angle. That's the same rule as the sine rule, just with reciprocal functions. The secant of 90 minus an angle is the cosecant. Again, that's the reciprocal function version of this rule. The cotangent of 90 minus an angle is the tangent, and the tangent of 90 minus an angle is the cotangent. Again, 90 could be replaced by a pi over 2. We also have some other weird properties where what happens if you make your x value negative, or what happens when you make your b value negative. The cosine of a negative version of an angle is the same thing as the cosine of the positive version of the angle. Same thing with the secant. Secant of the negative version of an angle is just the same thing as the secant of the positive version of the angle. Those are even rules. The odd rules come from the sine. The sine of the opposite of an angle, or the negative version of an angle, is just the negative version of the sine of the angle. You put the negative out front. Same thing with the cosecant of the opposite of an angle. That'll be the opposite of the cosecant of the angle. Same thing works with tangent of the opposite of an angle is the opposite of the tangent of an angle, or the tangent of a negative version of the angle is the negative version of the tangent of the positive version of that angle. And cotangent of a negative number, or an opposite number, is the opposite of the tangent again. Interesting. So note again that cotangent and tangent all make negative tangents. And these are going to be some of the most important ones, the composite properties, it's the sum and difference formulas. So the cosine of an angle plus another angle equals the cosine of the first angle times the cosine of the second angle minus the sine of the first angle times the sine of the second angle. Cosine, cosine, sine, sine, for any time you have cosine with two things. The other thing to notice is that the plus for a plus b becomes a minus when we expand it. Cosine again does weird opposite ideas. Cosine of an angle minus a second angle is cosine of a plus, times the cosine of b plus sine of a sine of b. Cosine, cosine, sine, sine, from a cosine a and b. But again, minus becomes plus. Sine kind of stays its own signs. So sine, cosine, cosine, sine is the pattern for the sine of an angle plus or minus another angle. So the sine of an angle plus the second angle would be the sine of the first one times the cosine of the second one plus the cosine of the first one times the sine of the second one. It always goes first angle, second angle, first angle, second angle, all through all of these. Same thing with down here with the tangents and on the next page. The sine of the difference of two angles is, again, sine of the first times the cosine of the second minus, because the sine just follows the sines directly, cosine of the first times the sine of the second. Sine, cosine, cosine, sine when you start with the sine. Cosine is kind of greedy. It goes cosine, cosine, sine, sine. And it's greedy, so it changes whatever you say the plus or the minus is when you expand it. Tangent is the tangent of angle A plus the tangent of angle B over 1 minus tangent A times tangent B. And then same thing when you switch the sign here, you're going to switch both of these signs. So the tangent of A minus B is going to be the tangent of A minus the tangent of B over 1 plus the tangent of A times the tangent of B. Those are the rules. Let's take a look at proving some of these or showing that they work. So, example 1, demonstrate that the given property really works by substituting 150 degrees for A and 120 degrees for B. So, if we substitute everywhere, then we're actually looking at the cosine of 150 degrees minus 120 degrees equals the cosine of 150 degrees times the cosine of 120 degrees plus the sine of 150 degrees times the sine of 120 degrees. We can simplify these by looking at, we can simplify the left side of the equation by subtraction, and we can simplify the right side of the equation by looking at the unit circle for equivalence. So we can turn the left side into the cosine of 30 degrees, since 150 minus 120 is 30. The cosine of 150 is actually negative root 3 over 2, if we look at that on the unit circle. Cosine of 120 is negative 1/2, plus the sine of 150 is positive 1/2, and the sine of 120 is root 3 over 2. So we're trying to prove that these are the same thing, so we're going to simplify the right, and now we're going to go to the unit circle to find the cosine of 30. The cosine of 30 is really root 3 over 2 equals, if we multiply here, we get positive root 3 over 4. Plus another positive root 3 over 4 from 1/2 times root 3 over 2. 1 root 3 over 4 plus another root 3 over 4 is 2 root 3 over 4. I'll move over here for the next part because I'm running out of space, but the 2 and the 4 both divide by 2, so we get that root 3 over 2 equals itself. So we proved that that rule actually works. Same thing with part B. The sine of the sum of two angles. If we look at the sine of 150 degrees plus 120 degrees, remember the pattern for sine is sine, cosine, cosine, sine. And again, it's first, second, first, second. So the sine of 150 degrees, first angle, cosine, cosine. And that'll be the cosine of 120 degrees, since 120 was the second angle, the B value, plus the cosine of 150 times the sine of 120. Simplifying here, we get the sine of 270 degrees. If we go to the unit circle for these values, the sine of 150 is 1/2. The cosine of 120 is negative 1/2. The cosine of 150 is negative root 3 over 2. And the sine of 120 is positive root 3 over 2. Going back to the unit circle again, the sine of 270 is negative 1. 1/2 times negative 1/2 is negative 1/4. Negative root 3 times another root 3 would be negative or minus. Root 3 times root 3 is just 3 over 2 times 2 is 4. So negative 1 over 4 minus 3 over 4 is negative 4 over 4. And negative 1 is the same thing as anything over itself. That's example 1. I will see you in the next video.